Okay, example one is understanding congruence. So before we look at the example, let's look at the next slide, which they probably should have put first. So it says figures that have the same size and shape are said to be congruent. So their length of the sides, the corresponding sides of the two figures need to be congruent, and then the angle measures need to be congruent as well. A rigid motion, which we talked about last unit, so that's your reflections, your rotations, and your translations, are sometimes called congruence transformations because it maps the pre-image to the image, and the pre-image and the image are going to be congruent. So we use the congruent symbol here when our two figures are congruent. So triangle ABC is congruent to triangle DEF. Okay, a couple things we notice here. Again, the corresponding sides on each figure are going to be congruent. So here, AB is congruent to DE, BC is congruent to EF, and then AC is congruent to DF. So this is a reflection over line M. So the pre-image and the image are going to be congruent. So you have your three sides, and then angle A corresponds with angle D. So they're congruent. Angle B corresponds with angle E, so they're congruent. And angle C corresponds with angle F, so they're congruent as well. And then when we look over here at our congruent statement, okay, the corresponding vertices of these triangles match up, right? So again, we said A corresponded with D, so we put A and D first. B is congruent to E, so those vertices on the triangles correspond with each other. So B and E are second. And then C and F correspond with each other, they're congruent. So that's why they're third there. Now you can write the statement. So we could name the first triangle BAC. Okay, there'd be 6 different ways to name this first triangle. You can name it however you want, but when you write your congruent statement, you have to match it up with the corresponding vertices. So B here is congruent with E, so we'd have to call this one triangle E. And then A is congruent with D. And C is congruent with F. So triangle BAC would be congruent to triangle EDF. So there's 6 different ways you can write the first one, but then in your congruent statement, you have to match it up appropriately based on the corresponding parts. Okay, so let's go back to our example and then look at what that's saying. Okay. So suppose there's a rigid motion that maps one figure to another. Why does that show that the two figures are congruent? Well, if you have a rigid motion, you're not going to change the size and shape of the figure. So all the corresponding parts are going to be the same length. All the angles are going to be the same. So your pre-image and your image are going to be congruent. So a rigid motion, the pre-image and the image are going to be congruent. Okay. And I think what they're going to do here is they're going to show that by showing all the lengths of the sides. So if you count out how long each of the sides are, right? A to B here is going to be 3. B to C is 1 unit long. C to D here is 1 unit long. DE is 2 units long. EF is 2 units long. And FA here is 3 units long. And if we look at the corresponding parts on the other one, so AB, right, is going to match up with HG. So HG, and I think if we scroll down, they'll have them written for us. Yep. So GH or HG, right, you can name it either way. That's 3 units long. So it matches up. AB matches up here with GH. And they're both 3 units long. Okay, BC is 1 unit long. It's going to match up with IH. So they match up because they're both 1 unit long. CD was 1. CD is going to match up with IJ on this one. And so on, right? DE is 2. JK is 2. Okay, EF is 2. KL is 2. And then FA is 3. LG here is 3. So all the corresponding parts are the same length. So since the corresponding parts are congruent, then the triangles are going to be congruent as well. Okay. So sides would be congruent. Angles would also be congruent. So all these angles here, angle A, B, C, D, E, and F, are going to be right angles. So all the angles there are right angles. And since all the angles here are right angles, those match up as well, right? Angle A is going to be congruent to, right, angle A is going to be congruent to angle G, right there, because they're both right angles. And you could go on and do the rest of them as well. Right? Angle B is 90 degrees. So angle B is going to be congruent with angle H, and so on. They're all 90 degrees. All the angles are congruent, and all the side lengths are congruent. Right? Angle measures are equal, so they're congruent between the corresponding angles here. Right? So A corresponds with G, B corresponds with H. They're congruent because they're 90 degrees. And then since the length of your sides, of your corresponding sides, are congruent, they're the same length. All your corresponding sides are congruent, therefore the figures together are all congruent.